Hey, getting ready for Math 6 pre-algebra. Oh, hello there. Hey, getting ready for Math 6 pre-algebra. Oh, hello there. Hey, getting ready for Math 6. Okay, so let's check this out. I just turned my sound down. Can you still hear me? Okay, great. So I'm going to leave my sound off. And then let's see, I'm going to get a good angle here for the board. Let me just turn this a little bit. Oh, maybe this way. Just so you know, everybody, there's going to be about a 5-second lag. Okay, and then remember, we're going to keep spamming to a minimum. It's going to be questions only. There'll be times where you could answer questions. Have some paper with you to do some problems. Writing materials. It'll be about an hour long. Okay, give or take. Let's see, can everybody see the board? That a little bit in front of the camera. That looks like a little bit of glare there, so let me tilt that back. It's not going to be up to me to tell you to skip. It's really optional how you're going to play this out. You can discuss that with your parents, and let them know that you've done a couple of these already, or just watch along. I mean, we're going to be doing this for an hour, so I don't think it'll hurt to get a little refresher anyway. This is lesson 8-6. I believe I put that in the title. I think you guys can see that in the title. I think the board can, I hope everybody can see the board well. Should be able to see the board well. If not, let me know. And we're going to wait just a little bit so people can check in. We won't start right at 10, but tomorrow we'll probably try to start as close to 10 as we can. And remember, we want to keep the message board open for questions, or if you guys are going to be giving me answers to things, that's fine. Good morning. Thanks for joining. Yeah, I would stay watching the video. We're going to there's only a couple slides away from where we left off anyway, so I might throw in some challenge problems and things like that, so you might as well just watch along. Make sure you can do these things. Okay, so just give it a minute or two. Those tuning in later, you can just fast forward through this part until we start. If you'd like, go ahead and see if you can graph those that are on the board already on a number line, single dimension. If you're waiting around, I can throw a challenge one in there for you. Why don't you graph this one? Y is greater than, no, let's do the absolute value of y is greater than, well, it has to be positive, so let's do 4. Try to graph that. See if you can do that while we're waiting to start. I'll call this one, well, we'll just leave it like that. Yeah, you can take notes. I would use paper. You should use paper unless you have a whiteboard like I do. So taking notes is a good idea. Just to answer the question on homework, you should do the homework right after we finish or today. The sooner you do it, the closer to when you learn it, the better. But we will turn it in when we get back. You can type answers when I ask you a question if you would like, but I don't want you to be giving the answers away, so wait until I ask you for the answers. Okay? For these, they're graphical. The answer, you're not going to be able to graph the answer on there, I don't think. Yes, you are going to get homework today was the question. So it's 10:01 now. I think we're going to go ahead and get started. If anybody missed the opening, then it's being recorded so they can go back to it later. All right, so let's get started. 10:01. We're going to end at about 11. So welcome everybody. Good morning. Hope everybody's staying safe out there, washing your hands, social distancing. We all have to work together as as a society to and be responsible as a society to help stop the spread of this virus that's going on right now. I do miss my smartboard. I had a geometry lesson this morning, so it is a little bit trickier to do it back on the old whiteboard, and it's small, so bear with any of those difficulties. But I think that overall it was a good experience, so I think we're going to be okay. All right, so if you don't know how to do it, that's totally fine. So let's go ahead and look at the first one, and I'll bring this slide back in just a moment. So the first one was A is greater than 6. Okay, so for A is greater than 6, here's your number line. All you need is in the middle you can put a 6. And then on to the left of it, make sure you get that right. That's a 5, and to the right of it, a 7. Okay, so if something has to be more than 6, then if it was equal to 6, let's say it was equal, how would you graph A is equal to 6? You'd put a point, right? A filled in circle, right where that is on the line. But now we're coming away from equality and we're saying it has to be more than 6. It can't be on 6 if it has to be more or to the right of 6. So we have to find a way to graph that. So students think, well, 7 is more than 6. So is that the answer? Well, this is saying A can be anything. So you really need to show all things, all values that are more than 6. So that value, but what about in between those two, right? So if you can always go in between, how are you going to cover everything? And the answer to that is that we're going to shade everything. So to cover all the infinite points, you're going to go ahead and thicken that line up, okay? And you're going to even shade. Why would we shade the arrow? Because we want to show that that goes on forever. All right, so you want to know that that goes on forever, so that's the shading. But how can we get infinitely close to 6 without going on 6 if A has to be more? It can't be 6. Well, we solve that by putting the open circle right there. Okay, and that's it. So that's what that looks like. A is greater than or to the right of 6. Mr. Knaus likes to call that a force field around 6. Nothing can get in there. Okay. All right, so let's look at the next one. Let's flip this around. The next one was x is less than or equal to -1. By the way, did anybody have any questions about this one here? Let me take a look. No, oh, okay, so can there be a vinculum above the arrow? No, the vinculums are only over numbers that take place after the decimal. Specifically, you can't put a vinculum, the bar over. You can't do that. That's not going to work. So this is how you do it. Okay, let's see. I don't understand that last question. A equals 6A equals 6A equals, that looks like spam. So make sure you don't spam, because if the same people keep doing it, I do have to remove you so that people can focus on the lesson. So try to keep it together. All right, so here we go. Let's go to the next one. All right. So that little symbol below the less than sign, and that's an arrow that points to the left, that means or equal to, less than or equal to. So now when you graph, put -1 right in the middle. To the left of -1 is not 0. Some students put 0. It's not 0. To the left would be -2. To the right would be 0. Okay. Now, what this little equal sign says is that x can be equal to -1. It can be right on it, like that. Or it can be anything less, and it's your job to graph everything that x can be. If you leave out even one thing that x can be, it's wrong. Okay? So you're going to shade everything less than -1. And you're going to shade that arrow in. And you can see the left side compared to the right side, I can tell. So when we do come back and take a test on this, when we come back from this leave and we review, I should be able to see when you graph, obviously, that this side is shaded and that's not. It should be clear. Okay. Yes, so fill in everything to the left, yes. Okay. And then if this didn't have that, like that, make sure that this is an open circle, right? If it does have that, fill it in. Okay? All right, so that should be pretty straightforward. Okay, let me skip to another one. Let's see. Let's jump down to, let's do E. So let's get rid of this slide. Let's turn this one, get rid of that one. Let's go here. Try this one. What are you going to do with this? Everybody try to graph that. Take 30 seconds and try to graph that on your paper. Now this one gets tricky because notice the variable before the variable was on the left. So if you look, variable on the left, variable on the left, variable on the left, variable on the left. Oh, I want to come back to that one, by the way. Now the variable's on the right. I wonder how you're going to graph that. So I'll give you 30 seconds. I'll look at your questions if you have any. Question was how many slides? Right now, you should have the lesson either printed out or on another device. You should be able to see and follow along with the lesson. Okay, so you can see. And it doesn't matter how many. We're going for about an hour. So it doesn't matter. We just go right on moving along. It's a 0. 0 is less than x. Can we think of this as x is greater than 0, somebody said? Can we do that? Well, we have something called in geometry, symmetric property of equality, which says that if A is equal to B, then B is equal to A. That's the symmetric property of equality. Okay? But this is not the case for inequality. If I am taller than you, then you are not also taller than me. So if A is greater than B, it is not true that B is greater than A. They cannot be switched that way. They can, but you can switch the way you say it. If A is greater than B, if I'm taller than you, then you are shorter than I. Okay? So look at that. If this one is larger than that one, then this one you can say is smaller than that. So if 0 is less than x, then you can say that x is more than 0. So the answer to that is yes, you can do that. And I recommend that you do. Because look, if you see left and you're going to shade left, you're going to get it wrong. This one you need to shade to the right. Okay? You graph the value of x, not place it on the number line. How does not have smart... Oh, smartboard? Yeah, I'm at home, definitely. And these are inequalities, yes. Okay? So, the correct graph for the original one, what do you put in the middle? You're going to put the number. 1 over here, -1 over there. Okay? This one you might shade everything to the left of 0, but you really need to be shading everything to the right. And open circle. And then shade. Okay? So it looks like that. Okay, and again, I'm going to tell you the cheese and apple comment, I would say let's hold off on those kinds of things. Um, and it's just going to disrupt the lesson. So only if you have a question, please. And, you know, first day I'll give you lots of warnings, but after that I'm going to have to just remove you. I want you to be able to ask questions. So, but if you do get removed, it's okay. You can watch the video later on anyway. Okay. All right. Before I give you another, well, let me do some of the others on the other side. Okay. Try this one, everybody. What happens if you have this? Try that. Take 30 seconds and see if you can make sense of that. Oh, the question was, can you put the variable on the number line? No, you don't put the variable on the number line. So let's go back to that. This is the answer right here. That's the answer. Notice no variable there. This shading represents what the variable can be. Okay? That was the answer to the previous one. Can you not NPC? I don't know what that is. Okay, let's hold off on telling other people. I can handle that part. Just only ask a question. You don't have to tell other people to be quiet or anything like that. Just hold off. Everybody hold off on your comments because it'll get out of hand real quickly. There's a lot of people tuned in. Okay. Question, can you bracket the shaded input X? No. I'm telling you right now, if you don't put your answer this way, you're going to get it wrong. This is the way we do it. So we're not going to do it in a different way. The X is not going to go there. This is what I'm grading. This has to be what your answer looks like. Okay? All right. So now I'm going to put it back on this one. Okay. We'll keep doing these until you get it. So do we shade it like that one on the test? Yeah, of course. Well, however I teach it to you, I'm not going to then change it on you for the test. That's what I'm teaching you. Okay, let's not talk about if you're in the class or if you're watching. It doesn't matter. Okay, and then the warnings are coming to a close, so I'm going to have to remove people that are saying things that you don't need to be saying. I apologize ahead of time. Yeah, I'm going to explain this problem right now. Okay, so here we go. You want to look at this as X has to be between, just like it looks here. It has to be between these two. So you need to get both of these numbers. You need to get them up onto the number line. So let me change up the color a little bit here. Hopefully you guys can see the orange. So let's see. There's -2, -1, 0, 1, 2, 3. Let's get rid of that. 4, 5. There's 5. 1, 2, 3, 4, 5. Okay. X has to be between. Now, here's -2 over here. X is to the right of that and not equal to. So you need an open hole here. Now here on the right-hand side, X is to the left of 5, so this one needs to be filled in. So just get a look at that for a second. Okay? Now, X can be anything in between those. So guess what you have to do to cover them all? Exactly, you have to shade it all. So you're going to do this. That's it. That one's filled in, that one's not. Why? Look up here. That one is less than or equal to. This one is just less than. -2 is less than X, which means X has to be more than -2, and X has to be less than or equal to 5. And there it is. Okay? Any questions? What about the X? The green in the graph represents the X. It represents everything X can be. Okay? Good. Why can't it be shaded and shaded whole? I don't understand that question. Why can't it be shaded? It is shaded and shaded whole. There's a hole there because x cannot be exactly -2. But x could be exactly 5 because of this little line. That symbol says less than or equal to. Let's see. Since the x is between -2 and 5, you shade the middle part. Exactly. Did we have to fill in all the numbers between -1 and 5? No. Between -2 and 5. Remember, there's these. Look here. There's -1. Here's -2. All of these are also to the right of -2. You have to shade it all the way to your circle there. It's not shaded because it doesn't have, look here. What's the difference between this arrow and that arrow? See this? There's no, this just says less than. Okay? This one doesn't say the same exact thing. It says less than or equal to. If x can be equal to 5, then you want to be able to land right on it. Filling it in shows that you can land right on it. Leaving it open means you are not allowed, x cannot land right on -2. And that's why you leave it open. Okay? All right. Okay, good. All right, excellent. All right, so that being said, let me throw this slide down, put up a new one, and let's everybody try to do this one. 40 less than or equal to x less than 45. Try that, 30 seconds. Try to graph that on your paper. This is 8-6. I'm not sure what, example 4. Are they two separate equations? It's interesting. You could separate them. That's an interesting way to think about it. Okay, so how would you separate? Now, I don't want to confuse anybody, but you could do this. You could think of it as that, and then separately, you could think of it as that. So what would happen if you rewrote those? Remember what we do when the variable's on the right, if you want to switch it, you might say x is greater than or equal to 40, and also x is less than 45. And this is what in algebra is called an intersection. It's only where both are true at the same time. So how can x be more than this, but it also has to stay under that at the same time? Well, that suggests what the graph would have to look like in order to make that true. Okay, let's see, 40, 1, 2, 3, 4, 5, there's 45. Okay, so in order to make that true, to be greater than or equal to 40, you can be equal to 40 or more, but you can't go on forever because of this other one. This other one limits you. You have to stay under 45, and you can't even land right on it because you don't have that equal sign underneath. So then you get an open circle. And then guess what? Everything in between. All of these fit the description of both. So these are constraints. These constraints tell you you have to be above or equal to 40, but you can't go above, you must be less than 45. Okay? All right. Is there glare? We could fix the glare. We'll just angle it a little bit. See if that works out for you. Maybe we need to angle it the other way. I don't know. Let's see. There's a little bit of a lag on this. That's a little better. Okay. Okay, good. Excellent. All right, so any questions about this one? Okay, all right, no questions. Okay, all right, so let's move on. This is an and. So if you notice that comes together, what happens if it can be one or the other? What if you throw in an or? And this is what in algebra we're going to call a union. Okay, so both can happen. Um, so this is what it looks like. And I want to see what you come up with. This has an or in it. Or, what do you think that that looks like? Go ahead and take 30 seconds and try to do that. Oh, question on the last one. Do you have to put all the numbers between negative 40 and 4? It was not negative 40. It was 40 and 45, I believe. Let's see. Yeah, positive 40, 45. Okay, positive 40, positive. So yes, all of the numbers, that's why we shade. We shade because you have to put all of them, and there's infinite numbers in between. So that's the only way we can do that, is to shade it. Okay, so the number line with only 40. Yeah, you don't want to have have 0 on all your number lines. So we can just put the numbers that are close to the numbers that we're talking about. X, well, you're saying X cannot be less than 2, but this says the opposite. It can be less than 2. Okay? But it can also be more than 5. All right? Those are the two options that you have here. So I wonder if any of you are graphing this properly, just on, just with your own intuition. Okay, question is, what if it is negative 40 and 45? Well, then, if it's negative 40, let me do a side. This is how I would do it. Put negative 40, and don't put tick marks. Just put 45 over here. You know? So you could even put a 0, right, if you wanted to. All right, you could put a 0 there, right? All right, but you don't need to do that. I'm not asking you to do that. Let's stick to this one now. Are they two different graphs? No, same number line, one number line only. No, don't choose one. You need to shade all possibilities. Yes, you can graph it on one number line. Let's see what you come up with. Okay, I'm going to start laying down the number line. Keep trying to do it. Let's see. Okay, here we go. I'm going to put 0 over here. 1, 2, 3, 4, 5. Okay, here it comes. Now, Galileo is saying, oh, I don't want to use names, I apologize. He's saying that for this one, you're going to use the force field, meaning that around 2, x cannot be exactly 2. So you have that open circle. Okay? So then, everything less than 2, your x is allowed to be. And I'm going to shade in that arrow because that goes on forever. Okay? And then this one, x can also be greater than 5, but not exactly 5. Another open circle. Okay? And then shade greater than 5. And if you look at this is called a union. All right? And they go apart from each other. The other ones came together. All right? Which is confusing because that you would think that that's called a union. But it's called an intersection, the other one, because it's where the two can be together at the same time. All of these are true for both at the same time. Okay, that's why it's called an intersection. When you see or, it's either can be true, but not at the same time. You cannot have a number over here that's also over there, can you? Think about it for a second. I know it's abstract, but think about that. Can you have a number here that also at the same time is over here? Not in, I can think of maybe something. What if this number line wrapped around a circle, right? Then you can go this way and come all the way around. But that's not what we're talking about. We're talking along a single dimension. Okay? All right. I don't like quantum physics. I don't know about that. All right. So graphs can look like this. They can go apart. They can come together. All right. Yes, you can graph two things on the same line. All right. And you just need some practice. Just to clarify, when you shade in the circle, it means equal to and greater. It's not that it's and. It means greater than or equal to 40. And remember, what you're shading in is everything that it could be. And if you leave one thing out that it could be, then you're not graphing it properly. Then you're graphing it incorrectly. Graphing means to show all possibilities that the variable can be. Let's see. -5 on the left of 0, and you're on another slide then. You're on this one. Okay, so let's see. -5 on the left of 0 and 2 on the right of 0. I don't know what you mean by that. One big force field around what? One big force field around what? Let's come away from force field. Let's say that that's an open circle. I don't necessarily like the term force field. It doesn't sound very mathematical. That was just for fun. But there's no, you can't make, I don't know where you would even put one open circle. It has to be where you would, it's in place of a point. Now, if you said, let's put one big point to cover the whole thing, right? You're just going to make a big circle and blob it all in. That doesn't make a lot of sense. So this is just like what a point would be, but it's to show you that nothing's there. Okay? All right, we're going to move on. All right, so let's see. Okay, let's get to that challenge one that I gave you guys. So I'm going to throw this one down. This was the challenge one. Throw in the absolute value. See if you could do that. Yeah, no spamming, please. We appreciate that. If you are, I'm going to have to remove you. What's with all the retracted messages? Let's not do that. Okay, no problem. Oh, got it. Intersection, not interception. Intersection versus union. Does the absolute value even matter? Yeah, it does matter. What does absolute value mean? Who knows? You can write it if you want. What does absolute value mean? Coincidence that all the message retracting or something? Forget about the message retracting. Focus on the lesson. Intersection is and. Union is or. But what does absolute value mean? You can clearly see absolute value of y is greater than 4. I think we're okay with the glare. Okay, distance from 0. So read this differently now. The distance from 0 of some number has to be more than 4. See if you can graph that. If you just think of it that way, it might be intuitive how to graph that. The distance from 0 must be more than 4. You can't, that one's like a restraining order. You can't come within 4 units of 0 because it's from 0. It's distance from 0. So you can even tell me what vocabulary word that's going to be. Is that going to end up being an intersection or a union? Right? Okay, so here it comes. Hopefully you had a little bit of time there to think that out. Okay, so you have your number line. Absolute value, we need 0 on there because we're talking about distance from 0. Distance from 0 has to be more than 4. You need to stay more than 4 away. Okay, somebody's saying intersection. I don't know if let's get it on there and then we'll answer that question. So here's 4 away, but you could also be 4 away in the other direction, right? All of these points are less than 4 away. They're all closer to 0 than 4, even on this side. So none of those would be part of your solution. Okay? None of these would be right because all of these are less than 4 away. You need them to be greater than 4 away, right? So to be greater than 4 away, first of all, you can't land right on 4, or on this side you can't. But everything to the right of that is more than 4 away forever. 1 million, way out here at 1 million, that's more than 4 away from 0. Or just 5 is more than 4 away. Or 4.00001 is more than 4 away from 0. And then you got to do it on the other side. Okay? So all of these points are more than 4 away from 0. So, looks like what? Does that look like an intersection? Can these be true at the same time that these are true? Can y be both this and that at the same time? It cannot. So when you can choose this or you can choose that, but not both at the same time, that's a union. Let me change it around on you. Any questions about that? Yep, one or the other, exactly. Can you clarify the difference between Yeah. Union is when it's or. Y can either be here or it can be there. But a number cannot be -5 and +5 at the same time. Okay, so it's one or the other. So that's what we call a union. Your answers, it's a union because your answers can be from, let's use this diagram here. Okay, your answers can be over here or it can be over there, and so your answers can be from A or from B. All right, you get to unite all your possible answers are part of your solution. All of these and all of these are part of your solution. So we're uniting all of our possible solutions. That's, I guess, the best way I could explain why that's a union. Okay? Now, union is the algebra. You guys aren't responsible for knowing union, but it's a useful thing to know right now. Okay, let's see. I don't know if I missed this, but why did you make the circle for -4 as well? Because -4 is 4 away from 0. On the test, are we allowed to skip numbers on the number line? Yes, but we will talk about that when we do the review, and you can ask that question when we do the review. Since it's absolute value, shouldn't it only be on the positive? No, because you can plug in a negative in there, right? Then you take the absolute value, right? I'm asking what y can be, not what the answer to this is. I'm asking what is y allowed to be. Okay, so y can be negative values. You can plug in negative values. Okay, let's see. Since it's absolute value, so can something be an intersection and a union? I don't know. You'd have to come up with an example. I don't think so. You might have situations where, what if I told you this? X is greater than greater than 4, or x can be greater than 5. But now we're kind of getting off task, all right? So I can say, you can either pick something that's more than 4, or you can pick something that's more than 5, right? Well, then you would just end up shading, here's 4, you would just shade everything, and that would cover both. That would be a union, okay? But I wouldn't say it's an intersection. But what if I change this to and? Now, that means both have to be true. Well, there is a possibility for both of them to be true. It just can't involve these values in between. Between 4 and 5, it's only true for this one. 4.5 is greater than 4. That would work. But it's not also, and that's what the and does. It also has to be true of this, and these numbers are not greater than 5. Okay? So then you would shade that with an open circle. This would be greater than 4. These are all the numbers that are both greater than 4 and greater than 5. Okay? So yes, you can do those types of things, but I don't think that makes it that makes it a union and an intersection. Okay, now what about this next one? Try that. All I did is I made that less than instead of greater than. And I'll work on the glare while you're working on the problem. Okay, I see people coming in now. You're saying union on this one. You think union, huh? Oh, I like that. You're trying to do that graph. Yep, that looks really good. Nice graph. Okay, so let's see. Some of you are coming in on this. So this means that the distance from 0 has to be less than 4. That means you got to stay close to 0. You can't go past, you can't even get to 4 or negative 4. Okay, so that means this and that and everything in between. That's an intersection. Okay, so that's how that one would be. That says that all of these are solutions because they are within 4 of 0. The distance from 0, that's what this means up here. That's how you can read it. Distance from 0 is less than 4. And if you're having trouble, look over here. If this point is at negative 3, how far away is negative 3 from 0? Is it less than 4 away? Yes. So that's why it works on the negative side. Okay. All right. Well, a little bit of glare on the side, it shouldn't be a big problem. Let's see how that goes. Let's adjust that. Okay. All right, we're going to move on. Don't focus so much on the glare. It's not going to be perfect. I think that you can see this clearly. All right, as long as you can see it. Now, if you can't see it, that's different. Okay. All right, so now we're going to move on. I think we got through that pretty thoroughly, so let's see what we have next. A little bit of a freeze up here. Okay, so now we're going to go the other way. I'm going to give you the graph, and you have to tell me the inequality. So that works well. So I want you to write the inequality now. This should be nice and easy. This one you can write right into the comment if you want. You can give me the answer to that one. And I'll do the next one too while you're doing that. What would the inequality for those two be? Don't worry about the difference between union and intersection. It's not part of our current curriculum. So I would just see if you can do the graphs, or take these graphs and write the inequalities. Yeah, you're going to need a variable when you write the inequality. I would have the variable on the left-hand side as well. That's just rule of thumb there. But I like that some of you are experimenting with having the number on the left. That's good practice. If you want to try that, you can. Okay, good. Answers are looking good. Okay, but this one's already graphed, so don't show me a graph right now. I want to see the inequality. Okay, so the first one looks like you guys are getting it. So x is greater than or equal to -3 is what you should have gotten for that. Okay, and then this one should be, it doesn't have to be x, you can call it y is less than -2 for that one. Okay, and that's straightforward. Pretty straightforward. If you switch the numbers around, it could be -2 is greater than y, which I'm seeing some of you doing. Oh, nope. One person did -2 is less than y. No, this is not y. This shaded part is y. The y is all the shaded stuff. So you don't look at -2 and say this is -2 is less than y. No, y is all this, which is to the left. Less than is to the left, okay, of -2. Okay, -2 doesn't move around. It's right there. All of this is what y can be. Y is a variable. It varies. So it can be any of these things. That's why we call it a variable. Yeah, so if you're going to mess around with it, it's -2 would be greater than y. Okay? All right. Let's see what we got on the next page. Ah, your favorite part. You know what's coming. You know what's coming. You know what's coming. Yay, my favorite part. Your favorite part. Okay, now, you will turn this in when we come back from break. Okay, so we will check these all. Just hold on to them. Don't let them pile up till the very end. Right before we come back, we don't even know when we're going to come back necessarily. So just have them done. Do it today. Right? You don't have to do it right away. Take a break if you want. It's not a lot of problems. Okay? It's I don't know, what is that? 15 problems or something like that? Not exactly. Okay? And they're like the ones that we did. They didn't take a long time. So you should be able to do this. Okay, pretty good on the lack of spamming is pretty good. We can try to work on that. We're not done. We still have 15 minutes, so we're going to go right ahead into the next lesson now. Okay. Next one is going to be 8, 7. That around. And let's see what 8, 7 brings us. Yeah, let's fix that glare while we're waiting for that to come up. I think the computer being this way maybe makes less glare. But then I don't know if you can see me very well. Not that you need to. No, that's more glare. So we want this way. Can we skip ahead on the lessons if we want to? Well, you're always welcome to skip ahead on lessons. Oh, I think that's pretty good. I don't see glare. Okay, good. I'm going to leave it right there. Okay, here we go. Apples are collected in a basket for 6 people. Okay. 1/3, 1/4, 1/8, and 1/5 of the apples are given to 4 people, respectively. So person A, person B, person C, person D. So we have apples are collected in a basket for 6 people. And we're going to give a third of the apples away to one person, a fourth to another, an eighth to a third, and a fifth to a fourth person. The fifth person, person E, let's see, gets 10 apples. So we know that they're going to get 10 apples total. Okay? With 1 apple remaining for the 6th person. Person F gets 1 apple. Okay? Find the original number of apples in the basket. That should be fun. Go for that now. Oh, there's glare again. I don't know why that keeps coming back. Okay, so let me repeat that problem. So you have 6 people that are going to get apples that are coming out of a basket. Okay? And let's see how that glare does when I turn that. Okay? That's okay for now. Okay, it just changes. And then you're going to give a third of them away. We're going to mess with the lighting a little bit here to see if that takes away. I think the glare is coming from that light, though. Yeah, so this one we would want on, I believe. Yeah. Thank you. Okay. Maybe not. It's going to switch. We're going to see here. Okay, so maybe that looks better. Took some of that glare out there. Lighting is not optimal. I might be working on another space tomorrow to do this, but I think we can see. All right, hopefully everybody's working that problem out. Did anybody find the original amount of apples? We're not going to tell other people to be quiet. Okay, so let me say the problem again. Okay, so here we go. You have a basket. It's full of apples. You don't know how many. You're going to give away to the first person a third of all the apples, a third of the unknown, which you can label with a variable. Then you're going to give a fourth of that unknown amount, and then an eighth, and then a fifth, okay, of the same amount. This is not a fourth of what's left after you pull out the 1/3. It's a fourth of the original, an eighth of the original, and a fifth of the original. Okay. Then you have 10 apples to go to person E and 1 apple to go to person F. So you're going to need to write an expression to do this. Okay, to find out what that is. Okay, I'm going to start working it out on another board. You keep working on it. Think about when you add them up, what would it be equal to? Oh, I better do this sideways. I'm running out of space to make it. Okay, so you might start by 1/3 x. For those that are saying you're not sure how to start, 1/3 of the original amount plus 1/4 of the original amount plus 1/8 of the original amount plus 1/5 of the original amount plus 10 plus 1. And what do you think that's equal to? The original amount. Should look like that. Answers are starting to come in. We don't know if that's right, so you have to try. If you're not sure, take a look at this. Simplify that down. What's your common denominator going to be? What's your common denominator going to be? It's got to be a common multiple of all of these. Okay, so think about what that might be. Could it be 40? No, because 3 is not going to go into 40. Okay, could it be what people are saying is the answer? 120 could be the common denominator. Okay, so how would I change all these fractions to have a denominator of 120? 3 times what is 120? 3 times 40. So then this one would be 40 out of 120x, which kind of gives you the amount of apples and gives you the total amount of apples if this is right. Plus 4 times what is 120? 30, right? This would be 30 apples out of 120x. Okay, and then what's 120 divided by 8? It should be 15. That's 15 apples out of 120. And then what's a fifth of 120? It should be 24. 24 apples out of 120. Plus the 10 and the 1 make 11, and that should equal x. Okay. All right. So where do you go from there? What do we do from there? Can you get rid of all the fractions? How would you get rid of all the fractions? Or maybe you want to add these all up first before we do that. 40 and 30 is 70. 85. 85 and 24 is 109. So we can shorten this down. 109 over 120x plus 11 is equal to x. Maybe we want to get, instead of getting rid of, I don't necessarily want to multiply 11 by 120 to get rid of the fraction. I might be able to just get all the variables on one side. So how about I subtract the 109 over 120? Which one is more, by the way? X or this fraction of x? Yes, this is a challenge problem. It's the warm-up for the next lesson. Can you answer that question? This is a fraction of the whole. Okay, so this is more. So subtract this one from both sides. Let's see what we get. Let's go on another board here. Let's put up that equation that I had. I had this. And that's 1x. Okay? So if we subtract this from both sides, what do you get? This goes to 0. How far is 109 from 120? It's 11, right? You get 11 1/20ths x. Okay? Right? 11 1/20ths and 109 1/20ths add up to 120 1/20ths, which is 1x. Okay? All right? So now, how do you get rid of a fraction? You're going to multiply by the reciprocal. Multiplicative inverse. That's going to give us a 1. Let's do it over here. 120 over 11. Okay? X is equal to, the original amount of apples is 120. You guys did a great job. A lot of you got it. If you didn't, that's okay. If you could follow the logic along, that's what I need from you. Okay? Anybody have any questions about this? If not, we can move along. It's 55 minutes. It has not been almost 2 hours. Okay. If you don't get it, that's okay. What we can do is when we come back in from break, if you're interested in that problem, that was a challenge problem to get you to warm up that brain of yours. So it's not necessarily one of the things that you have to be able to do. We would like you to be able to do it at some point. So if you'd like to work on that, when you come back in, make a note of that problem, and then we can work on it when you get back. Okay, it's a little bit difficult to break it down more. I could review it a little bit. Let me just go over it one time. So here's what we said. We said in the original problem, okay, guys, hold your comments for a second. Don't tell us what time it is or how much time there is left. You're not obligated, so if you don't want to watch, then don't watch. Okay, we're going to keep going here. Okay, we're almost done, but don't keep reminding us that we have 5 minutes left. Okay, so we said there's a basket of apples. I'm going to do this quickly. We said that there's a basket of apples. Let me just answer this one question real quickly. You would email me through Schoology once it comes back on. It might already be back on. It was down this morning. You can, but I'm going to go over this problem briefly now. I don't want to break it down later in an email exchange. That's not fun to do. So I'd rather do it live like this, and then if you still need it, come back in when we come back from leave, okay? All right, so here's the problem. I'm going to do a summary. We had a basket of apples. We don't know how many, X. We're going to give a third of that away to A, a fourth of it away to B, an eighth of it away to C, a fifth of it from D, and what will be left is 11 apples. 10 goes to one, 1 goes to the other. And so we turn that into an equation. A third of the X, now define your variable. X is that original amount we don't know. A third of it is when you multiply them. A fourth of it, an eighth of it, a fifth of it, plus 10, plus 1. That's what everybody is given. If you add up what everybody's given, it adds up to the original unknown amount. That's how we got that equation. After that, I just got a common denominator of 120 here, okay? And then so that I could add the fractions together. And they added up to this. Don't forget the 11. Okay, then here's that equation. I just subtracted this fraction from 1. So it's just fraction work that I think is messing you up, if you're getting messed up on this. But I subtracted the same value on both sides, this fraction of X, and it comes out, if you think of this as 120 over 120, then you could subtract 109 over 120. Same denominator. 120 minus 109 is 11 over 120. And remember, that's of X. Okay? Over here, it canceled out, leaving you the 11. Then, to get rid of a fraction, you multiply by the reciprocal on both sides. It cancels out the 11, leaving you what X is, 120. Okay? So that, you can rewind it if you'd like and just look it over and pause it so you can absorb the information. Okay, probably going to look at what we're getting into, and we're not going to get too far into it because we're getting close to a stopping point here. Okay, so let's see what we have here. Oh, okay. We can come back to that to warm up tomorrow. That's another thought-provoking. Okay, solving inequalities is what we're going to be getting into tomorrow. All right, so that would be like an equation. You might have something like this. 2 times x plus 5 is equal to 30. And how would we solve that? Right, we could distribute first, or we could divide by 2 first, right? Okay. Right. X plus 5 is equal to 15. Subtract 5. X is 10, right? Well, what happens if this is an inequality? What if this has to be greater than 30? Okay, well, you do the same, everything the same. Divide by 2, subtract 5, and this is greater than. But there are some instances where that sign is going to need to turn around, and that's what we're going to be discussing tomorrow. So that idea of that when you go to inequality, there are some different things that might happen to you as you're solving along the way. That's what we're going to pay attention to tomorrow. Now it's about 11 o'clock, so I think this is a good stopping point. You guys did a great job. So we're going to start again tomorrow at 10 o'clock. For the rest of the day, if you have any questions, I will go back and check my Schoology from time to time. Do that homework assignment I gave you for 8-6. And see if you can get it done before we meet again tomorrow so that information is fresh in your head. Okay, so I just got a message Schoology's working, so you can ask me questions on Schoology now. All right, take care, guys and girls. I will see you tomorrow.